Hello students, this is Mrs. Raro and I am here to teach you how to simplify fractional exponents. Okay, so when you have, say, a base and it's raised to a fraction, this fraction actually represents radicals, okay? So for example, if your base is 49 and 49 is being raised to a half power, the power indicates a root, okay? So the denominator here is your root, which belongs here. And then the numerator here is actually the power of 49, the base, okay? So this is power over root, okay? So again, power over root. If you would like a way to remember that, just imagine solar power, right, over roots, like the roots of the tree, right? Roots. All right, so power over roots, solar power over root. Okay, cool. So, and then backwards as well, if you see a radical sign that actually represents that it had a base, so this is your base, 27 is your base, this was the power, which is in the numerator, and then this is your root, okay, which is in the denominator, okay? All right, so again, general rule of thumb is if you have a base and it's being raised to a fraction, that means A was your power, that's the power of x, and B was your root. So B is outside the radical and then A is inside the radical. You can also rewrite this as B in the outside, so the square root, radical, and then B on the outside, so the B, and then the base is x, and then you can take this and then raise it all to the power of A. That's also the same. All right? Okay, so let's begin some examples. So for example, if I have a base of x that's being raised to the 1/5 power, when you convert this into a radical form, this is your power and then that's your root. So that's the 5th root of x to the 1st power, okay? Let's take a look at the second. So again, x is your base, 2/7 is your power, so your the exponent. So this is power over root. So that means this is the 7th root of x squared or the 7th root of x all squared. Okay? All right, let's take a look at this one, and I want you to see if you could do this on your own. Okay, let's take a look at your answer. So hopefully your answer is the 4th root of x. All right, when it's the power is 1, you don't need to write 1. Okay, let's take a look at a second one. All right, so again, same idea. Pause this video and see if you could do this on your own. Okay, so this is x to the 1/5. So this is going backwards now. So they're giving you a radical form. They want it in an exponential form. Okay. All right, let's take a look at a second problem like that. Again, pause this video to see if you can do this on your own. Okay, so this is equivalent to x as the base and then 4/5 as the power, the exponent. Okay? All right, last one. Pause this video and see if you could do this on your own. Okay, so the answer to this is x to the power of 2/3. All right, so I hope you have a good understanding of this fractional exponents rule. All right, so let's take a look at more examples, but this time I'm going to combine the rules. So this is a combination of rule power to a power rule, or raising it to a power. And then let's see what this looks like. So it looks like we have x squared being raised to the power of 5/2. So if you apply the power to power rule, that means I'm going to multiply my powers together. So this becomes x to the power of 2 times 5/2. So in red, I'm going to perform 2/1 times 5/2. So these two will cancel out, leaving you with a power of 5. So this becomes x to the 5th power. So that means that A is equal to 5. Okay? All right, let's move forward to another one. All right, so this is x to the 1/5 and then all being raised to the third power. So again, I'm going to apply the power to power rule. So this is x to the power of 1/5 multiplied by 3. And again, in red, I'm going to multiply out my fractions. And then this is going to equal 3/5. So this is x to the power of 3/5. So we know that a is equal to 3/5. Now, if they ask you to rewrite it in a radical form, then the radical form would be the 5th root of x to the third power, or the 5th root of x all raised to the third power. Okay? All right. Why don't you see if you could do this one on your own and then see if you can figure out the value of a. And if the value of a is a fraction, please try and see if you can reduce it to a radical. Okay, so let's take a look at the rule here that we have to apply. So this is not the power to a power rule. This is a multiplication rule. So you have to add the exponents. So this becomes x to the 1/5 plus 4, okay? So, or 4.5. But remember that when you have a fractional exponent, you want it to be an improper fraction. So I'm actually going to do the butterfly method here, if you remember what the butterfly method was. So I'm going to apply 4/1. So this is going to become 1. This is going to become 20. And then this is going to become 5. So this is 1 plus 20/5, which is 21/5. Right? So this becomes x to the 21st power over 5, which is your root. And if you were to rewrite this, this becomes the 5th root of x to the 21st power, or the 5th root of x all raised to the 21st power. Okay? Again, this is a mixture of rules that you've learned in the past. All right, let's take a look at a second one. Actually, let's do this one right here. So this is x to the 5th power divided by x to the 2/3 power. I want to know what a is, and I want to know if you could rewrite that if it needs to be in a radical form. Okay. Okay, so let's take a look at how to find out the solution to this. So we have x to the 5th power divided by x to the 2/3 power. That means I'm going to subtract my powers together. So this is x to the 5th power minus 2/3. So again, I'm going to do my butterfly method of 5/1 minus 2/3. And then this becomes 15, and these two multiplied there. And this one becomes 2, and this one becomes 3. So this is the difference of 15 minus 2/3, which is 13/3. Okay, so this is equivalent to x to the power of 13/3. Or when you rewrite this, this is the 3rd root of x to the 13th power, or the 3rd root of x to the 3rd root of x, and then all raised to the 13th power. All right, so I hope this is all making sense to you, right? So, and it's all a combination of all of what you've learned in the past. So another thing that you've learned in the past is also negative exponents. So this is quite a little bit more advanced in simplifying this, but we could definitely do this in multiple ways. So again, I'm going to reiterate that this is the division rule. You can think about it that way, or you can switch them out because this one has a negative exponent in the numerator, and this also has a negative exponent in the denominator. So I'm going to switch them out as positive n to the positive 6th power and n to the positive 4th power. And then so this is the 8th root of each one, right? So this actually becomes n to the 6th power divided by n to the 4th power is actually n to the 2nd power. And now if you did n to the 2nd power and took the 8th root of that, this becomes n to the power of 2/8, which becomes n to the power of 1/4. So that's one way to do it, okay? Here's another way that you can do it, and then again, there's multiple ways. So you can say this is n to the power of -4/8, right, divided by n to the power of -6/8. Okay, so that's kind of the same idea here. And then you can switch them if you'd like, or from here you can say this is n to the power of -4/8 minus -6/8, which becomes n to the power of, well, this becomes positive, so positive 2/8, and now this becomes n to the power of 1/4. So either way you could do that as well, okay? Still arrive at the same answer. All right, well, why don't you take a look at this example and see if you could do this all on your own. Okay, so I hope you have the idea, right? You could do this again two ways. You can either raise this into the power of 1/6 and this a power of 1/6, or you can apply the multiplication rule here and then raise it to the power of 1/6, which is what I'm going to do. So I'm going to simplify this first. So this becomes h to the negative 7 plus 3 because they're being multiplied. So this becomes h to the power of negative 4, okay? So I have h to the power of negative 4 altogether that's being raised to the power of 1/6. And now I'm going to apply the power to power rule, and I'm going to multiply out my negative 4 times 1/6. All right, and that becomes h to the negative 2 over 3. Okay, and now I can actually apply, from here I can apply my fractional rule. So this becomes the third root of h to the power of negative 2. By the way, if you ever have a negative fractional exponent, the numerator is always the power, right? And now I can apply another rule right here, which is the negative rule of the third root of 1 over h squared. Okay, and that is your final answer. So this is multiple rules all in one. All right, and that is it. Thank you so much for watching this video. Bye.